All right, so in this video, we are going to talk about the affine cipher, a slightly more complicated cipher than the shift cipher that we've already talked about. But in order to talk about this, we're going to review the shift cipher. So for the shift cipher, remember there were sort of 3 steps that we did as a more mathematical way of encrypting a message. So the first step was we changed every letter into a number. All right, so we have an alphabet with 26 letters in it. So A got mapped to 0, B got mapped to 1, all the way up to Z being mapped to 25. The second step was we added the shift key to each of those numbers. Essentially, we shift all the letters by the key. And we do this mod 26 so that we can wrap Z all the way around back to A. All right, and then step 3 is we change all of the numbers back to letters. All right, so we saw an example of this when we did the video on modular arithmetic. So this is why shift cipher is sometimes also called the additive cipher. So this leads us to the obvious question: what if instead of adding to those numbers, we multiply? Still mod 26. Okay, what happens? And it's actually kind of interesting. It's not quite as simple as before. So let us change all the letters into numbers and then multiply each of those numbers by 2. All right, and so what are each of the letters going to be encrypted into? And so we can take a look at this right here. I've got a nice table that shows, okay, A is being mapped to B. All right, B gets mapped to D. C gets mapped to F. D gets mapped to H, and so on and so forth. Okay, so it's a little bit more complicated, but honestly, it kind of makes sense. All right, numerically, we could do this. But if we take a look a little bit closer at this, we see that there's actually a problem. And that problem shows up right here and right here. There are 2 letters that both get encrypted onto P. And in fact, the same thing happens with Z. And the same thing happens with R. So when you try and decrypt, if your ciphertext message has a P in it, you don't know if the plain text is supposed to be an H or a U. All right, so it's not really possible for you to decrypt your message uniquely, because every time you see a P, is that supposed to be an H or is that supposed to be a U? And so multiplying by 2 actually doesn't work. That's not going to be an appropriate cipher because we're not going to be able to decrypt it correctly. What if we instead multiply by 3? Well, we get this one right here. A goes to C, B goes to F, K goes to G, R goes to B, everything works. And if we examine this a little bit closely, we see that everything is being mapped to a unique letter. And every letter can then be mapped back to a unique letter. So this bottom row right here, every letter is only showing up once. All right, and so this is an encryption method that we can actually use because then we can decrypt it. Every time we see an H, we know it has to be a T. All right, there's no possibility for it to be anything else. So there's something different between the number 2 and the number 3 when we're doing multiplication. And you have all watched the units video now. And so one of the things that we know to be different is that 2 is not a unit, mod 26, and 3 is a unit mod 26, and that is the key. When we're doing this multiplication, we need the number we're multiplying by to be a unit. All right, there needs to be something that we can multiply by it to make it go away. There needs to be the equivalent of 1/3. And so the only things that we are allowed to use in this multiplication cipher are the units. And so for mod 26, that is 1, 3, 5, 7, 9, 11, 15, 17, 19, 21, 23, and 25. It is all the numbers from 0 to 25 that are relatively prime to 26, that don't share any factors with 26. And so these are what are called the multiplicative keys for the multiplicative cipher. All right, so these are all the possible keys that we can use, all the possible things that we can multiply each letter by in order to get a nice, unique encryption algorithm. All right, one that we are able to decrypt using a computer. All right, so this is the multiplicative cipher that we can use. And it's nice. There are 16 keys here. But that's actually not as good as the shift cipher even, because remember, for the shift cipher, we were able to have 26 keys. And so this is even going to be less secure than the shift cipher. Well, why are we talking about this if it's not even as secure? Because we are going to combine the shift cipher and the multiplicative cipher together to get what is called the affine cipher. All right, so for the affine cipher, what we're going to do is actually do both. So first, we go from letter to a number, mod 26. All right, and so this number, I'm just going to call it x, all right, just so I have a way of referencing it. Next, what we are going to do is we're not just going to multiply those numbers x, and we're not just going to add the numbers x, we're going to do both. All right, so we are going to have a key that has two numbers to it, s and t. All right, and in order to get the encrypted letter, what we're going to do is take s times x plus t. All right, so for example, in order to do the encryption, what we might do is take the number associated with this letter and do 3x plus 12, say. And this 3x plus 12 is going to be an operation that we do to get our encrypted letter. And then, of course, we take this number right here and switch it back into a letter to get our ciphertext. All right? And so what this is, it's just a combination of the multiplicative cipher and the shift cipher. All right, so we'll end off with a nice example. Let's take a look at A, B, C, D, E, F, G, H, I, J, K, L. All right, so the original number associated with all of these, I'm going to write them down. All right, and we are going to use the key 3, 2. All right, so 3 is the multiplicative key, 2 is the shift key. All right, and it's always written in that form. All right, the multiplicative key going first. All right, so to figure out what 0 gets mapped to, for instance, well, we're going to do 3 times 0 plus 2. All right, that was pretty easy. It gives us 2. So that tells me that A is going to be mapped to the letter with 2 in it. So A is going to be mapped to C. All right, so what about B? All right, so where does the number 1 go to? 3 times 1 plus 2, that gives me a 5. So B is going to get mapped to the letter 5, so F. All right, what about 2? All right, what about the letter C? 3 times 2 plus 2. All right, so that's 6 plus 2, that's 8. All right, so 2 gets mapped to 8, which means that C gets mapped to I. We'll do one more. All right, so D, that's 3. So 3 times 3 plus 2. 9 plus 2 is 11. All right, so 3 goes to 11, which means that D goes to L. All right, and we keep on going all the way through here. And so why is this more important? We're going to talk about that in the next video when we talk about the security of all of these ciphers that we have talked about so far. All right, so see you in the next video.